Hello, let us see the stability of CT LTI systems in S domain, Laplacian domain, in terms of region of convergence of CT LTI system. When it is supposed to be a stable system, how it should be, and in terms of location of poles, especially to understand the stability of a causal system. To understand the stability of causal systems. Let us take H of S. H of S is equal to integral from minus infinity to plus infinity, Laplace transform of impulse response of the system. So we know S is equal to sigma plus j omega. So we have restated that because S is equal to sigma plus j omega. Let us evaluate for sigma is equal to 0 condition. So H of S will become integral minus infinity to plus infinity H of t into e power minus j omega t into dt. Or we can even rewrite the same expression into integral minus infinity to plus infinity e power minus j omega t into h of t dt. Just rearrange the expression so that it will look like integral u dv. Yes, let me call this e power minus j omega t as u, and dv probably integral, or h of t is considered to be dv, right? If I imagine u is equal to e power minus j omega t, then this du will become minus j omega into e power minus j omega t. Similarly, dv, if it is assumed to be h of t, you can understand that v will become simply integral h of t dt. So using these assumptions with respect to this formula, h of s is equal to integral minus infinity to plus infinity e power minus j omega t into h of t dt can be expressed as integral u dv will be written as uv minus integral v du, isn't it? So uv, what is u? E power minus j omega t. What is v? It is simply integral h of t dt minus integral v du. Integral v du. V, what is v? Integral h of t dt. Du, what is du? It is simply minus j omega into e power minus j omega dt, right? So the limits of integration is minus infinity to plus infinity. For a stable LTI system, stable linear time invariant system, we know that the condition integral h of t dt is a constant. If so, what will happen to this h of s? Think about it. E power minus j omega t will remain as such, right? And then the constant, this is a constant a minus integral, this is considered to be a constant, minus j omega into e power minus j omega t dt. Yes, lower limit is minus infinity, upper limit is plus infinity. Same sentence can be modified into assuming a as a common factor outside. So it will become e power minus j omega t plus, notice that it will become plus a into a is already taken outside. So it is simply j omega into integral e power minus j omega t dt, where the lower limit is minus infinity, upper limit is plus infinity. H of s is to be evaluated, is the evaluation of Laplace transform for s is equal to j omega. It is the evaluation for s is equal to sigma. It is not sigma plus j omega because we have assumed already that sigma is equal to 0. So it is the evaluation of s is equal to j omega, evaluation of h of s along imaginary axis. See, when you take sigma is equal to 0 in s is equal to sigma plus j omega, it is understood that we are trying to evaluate this over imaginary axis. Evaluate h of s over imaginary axis. Evaluate h of s over imaginary axis. So we can say that h of s exists. H of s exists if the RoC includes the imaginary axis. What is that imaginary axis? S is equal to j omega. So for a stable system, for a stable LTI system, the RoC region of convergence should include the imaginary axis. An important concept which is not that much understood clearly by the signal processing engineers of S-plane. S-plane. Very, very important. Keep it in memory so that if any such question arises in signals and system, especially from one word part, we will be able to give the correct answer. Should include the imaginary axis. Similarly, in terms of location of poles, how it should be? Location of poles for stability analysis. We know that the LTI system accepts an input. H of t is its impulse response. LTI system is modeled like this. X of t is its input. Y of t is its output. What is H of t? H of t is called the impulse response of the system. LTI causal system. I am trying to confine this discussion only for LTI causal systems. So, what is the condition to be satisfied? Integral from 0 to infinity, h of t into dt should be less than infinity. Is the condition should be satisfied. So, LTI continuous time causal system. For a system to be stable, continuous time CT LTI system. CT LTI system to be stable is to be stable where the condition to be satisfied is 0 to infinity, h of t dt should be a value less than infinity. Right? Let's just move further. Let h of t is equal to e power at u of t. Now, let me evaluate the condition 0 to infinity, h of t dt. How will it look like? Because h of t is e power at u of t and dt. As you all know, u of t determines the condition that the signal will exist only from 0 to infinity on positive scale. Already the integral is from 0 to infinity only. So there is no role for this u of t. I'll limit it so that it will become e power at dt. Correct? When you integrate it, this will become e power at divided by a, where the lower limit is 0 and upper limit is infinity. Now you can notice that this will become e power 8 into infinity by substituting upper limit, and by substituting lower limit a into 0 divided by a. Now there comes a question. This will be e power a into infinity divided by a minus 1 by a. Here we have to make analysis about the condition to be satisfied. I'll tell you, at the last situation, 0 to infinity integral h of t dt is like this: e power a into infinity divided by a minus 1 by a is the condition. If a is a negative number, what will happen? Can you just imagine? Negative number, let me say it is equal to, say for example, minus k, right? Where k is positive, that is different. Now you just take the condition h of t dt, so it will become a is to be replaced by minus k, isn't it? Minus k into infinity divided by minus k minus 1 divided by minus k. So this equation will get reduced to minus k into infinity divided by minus k plus 1 by k. Agreed? E power minus infinity, it's a positive, k is a positive number. We have already told you that k is a positive number. So k into minus k into infinity will lead to minus infinity only. So I'll say this is equal to e power minus infinity, which is 0 divided by minus k plus 1 by k. You will notice that this reduces to a constant. Yes, the condition is satisfied. What is the condition? Integral. What is the condition? Integral 0 to infinity h of t dt should be a constant. Did you arrive at it? Yes. Only when you assume a is a negative number, that too minus k. This happens. So I'll take that this is a valid condition. A should be a negative number. A should be negative in the sense, on a real line, a must always available on the left hand side. On the left hand side. Keep this in your mind. Right? Let me go to the second case. If a is a positive number, how will you represent the positive number? Say for example k. If you take the condition 0 to infinity h of t dt, it will become e power, what is it? A into infinity. A is a value which is constant, k positive number, k into infinity divided by a is replaced by k, minus 1 by a is a positive number, so I'll just put it as k. Now you can find out that this is equal to positive number e power infinity. E power infinity is infinity by k minus 1 by k. Once you find out that this contains infinity by k, it will become infinity. Infinity minus anything is infinity. So I should say that the condition integral 0 to infinity h of t dt is equal to infinity. The system will become, the system, causal system will become unstable. Right? I'll summarize. For the LTI system, LTI causal system to be stable, for LTI system, causal system to be stable, what is to be covered up? Integral from 0 to infinity h of t dt should be a value less than infinity. This is possible if h of t is equal to e power a t u of t and a is a negative number. A is a negative number. Then only it was made possible. Right? then only the system will be stable. Agreed? Yes. I'll go to the next condition. For the stability of an equation, right, condition can be transformed into as a condition of location of poles of transfer function. Consider S-plane. The S-plane, you know that this area is called left hand part and this is called right hand part. You can identify over the vertical axis the j omega values will be present. Over the horizontal axis you will have sigma values. The transfer function of a continuous time system, say for example when h of t is equal to e power at u of t, as you all know, if I apply Laplace transform, this will become simply 1 divided by s minus a. But we have already told you some condition. The transfer function will have a pole. What is the location of the pole? Pole is at s is equal to a. Pole is situated at s is equal to a. Already I have stated some conditions, right? If a is less than 0, that is, if a is negative number, then the pole will lie on the left half of the plane, left half of S plane, right? Therefore, the system will become stable. Right? If a is a positive number, the pole will lie on the right of the S plane. We can say that the causal system will become unstable. So I'll summarize the condition, including the condition of RoC and location of poles like this. For a stable causal system, for a stable LTI, first of all LTI CT system, I'll say that is a causal system. The poles should lie on the left half of the S plane, and the imaginary axis should also be included, in the RoC. Right. For a stable LTA system to be a causal system, the poles should lie on the left half of the S plane. Also, it should include the imaginary axis in the S plane, in the RoC especially. Right? So these two conditions can be extended over different h of t values. For example, I have h of t is equal to a e power minus a t u of t. It is a causal system because the impulse response is e power minus a t only for t greater than or equal to 0. So it is a causal system. But if you look at h of s is equal to a divided by s plus c. What is the pole? The location of the pole is at s is equal to minus a. So if you take the RoC includes RoC, right? The pole is at s is equal to minus a. The RoC is shaded and shown like this on the S plane, right? It is shown like this. You can notice that sigma is equal to minus A. Sigma is equal to minus A is the abscissa of region of convergence. Abscissa of convergence. And RoC includes imaginary axis also. RoC includes imaginary axis also. So the pole lies on the left of the plane and the imaginary axis is included in the RoC. The RoC is actually, RoC includes the imaginary axis. The pole lies in the left half of the S plane. What is the first thing? I'll go to the condition number 1. Like this. Pole is at left half of the S plane. Of S plane. And RoC includes J omega axis also. Therefore, the system is stable system. That's how you have to identify from its impulse response. From the impulse response, you have to identify the poles. From the poles, you have to say whether the pole is located on the left half of the plane or not. And you should also determine the region of convergence. If the region of convergence includes imaginary axis also, then only you can declare that the system with that impulse response will be a stable system. So, this gives an idea. Depending on h of t and its general representation, if it is e power minus at u of t, right, where a is a positive number and its corresponding Laplace transform, which tells us about the location of pole. The pole is at S is equal to minus A. Therefore, RoC must be a value greater than sigma. RoC is sigma greater than minus A, where sigma is a real part of S, isn't it? And if you look at the RoC starts with the margin, where is the line passing through sigma is equal to minus A, and it includes the imaginary axis. Region of convergence includes imaginary axis. Imaginary axis is also included. This is RoC. So pole lies on the left half of the plane. Pole lies on the left half of S plane. Okay. And RoC, not only that, RoC includes imaginary axis also. This pole lies on the left half of the plane, S plane. The imaginary axis is included inside RoC. Therefore, the system will become system is a stable system. The system is a stable system. Similar to this one, I'll take the second example. H of t is equal to a e power minus at, but this time they have taken the impulse response as an anti-causal sequence. A greater than 0, right? Anti-causal. If so, h of s is equal to minus a divided by s plus a. The pole is at s is equal to minus a alone, but RoC is sigma less than minus a. Sigma is the real part of s. If we plot the RoC, you will find out RoC is the left side of the region to the line passing through sigma is equal to minus A. Right? You can notice that pole lies on the left half of the S-plane, but RoC does not include j omega axis, but pole is at left half of the S-plane. So you can declare pole is at the left half of the S-plane, but RoC does not include j omega axis. Therefore, the system is unstable system. Because for a system to be stable, the pole must lie on the left half of the S-plane and the RoC must include the imaginary axis. The condition is violated. So, that was unstable system. Now, I'll go to the next one. When I have h of t is equal to a into e power at u of t, right? We just take a causal system. A e power at u of t, where a is a constant and it is a positive constant. Causal system. What would be the h of s value? Everybody knows that it is h of s is equal to a divided by s minus a. The pole, what is the pole? Pole is at s is equal to plus a. What is RoC? RoC is sigma greater than plus a. So when you imagine the S-plane like this, the pole or the region of convergence is the region to the right side of the line passing through. Sigma is equal to A. And you can notice that the RoC does not include j omega axis. And the pole is also available on the right half of the RHP alone. Pole location is also at right half of the S-plane and RoC does not include. So you can declare the result. The system will be an unstable system. Unstable system. That's all. So it is very clear. From the impulse response, h of s is calculated. From h of s, we need to locate the poles. Not only poles, we should think about the RoC also. The RoC the RoC includes imaginary axis, then there is a chance, and the pole must also be located on left half of the S-plane.